The next data structure in Python that I'd like to mention is known as the tuple. A tuple is like a list in that we can hold a sequence of one or more values, and those values can be of any type, but unlike a list, tuples are immutable. That is to say, we cannot change the value within those tuples once we've created them. Because tuples are immutable, it makes them a little bit faster than lists, and it makes our code that uses them a bit safer, so we don't have to worry about aliasing or unexpected modifications. But these advantages come at the cost of mutability, which allows us to take one list and modify it over time. So tuples are ideal for organizing data that we expect shouldn't change over time. Now, tuples are also called tuples. The odd name and minor controversy over it, either tuples or tuples, sometimes Tuples, all stem from the ordinal number series, like double, triple, quadruple, quintuple, etc. So the term tuple, or tuple, is short for the ability to make ordered triples, or ordered doubles, or ordered octuples, as it would be. The syntax for making a tuple is as follows. We use round brackets, and then we separate our items by commas. Then we can access and slice that tuple the same way we would with any list or string. In Python, we can make a tuple by saying some variable equals, and then a literal tuple, so round brackets, and then I'll just put some values, 5, 7, letter A, number 3.14. And that gives us a tuple, or tuple. We can access individual items from there, so I can say tuple at 0, and that's the first one. I can say tuple at -2, and that's the second last one. I can do slices, so I can say tuple from 2 to the end, and that's the last 2 items. Note, if you omit the parentheses, you still end up making a tuple. So if I say tuple equals and then the same values 5, 7, A, 3.14, but omit the parentheses, then we end up with the exact same value, a tuple with those values in it. If we want to make a tuple with only one element, that is to say an ordered single, which is rarely useful to have but requires special syntax, we would say something like my single equals, and then in round brackets, the value I want to use, and then an extraneous comma. Even though I'm not separating values, the comma there is what tells it to turn that into a tuple, right? As opposed to if I just said my single equals 1 in brackets like this. A 1 in brackets is just the integer 1 with some extraneous brackets that get ignored. So my single would just be an integer. Whereas if I include the comma, then it's saying make this a data structure that only happens to have one item in it. All right. So we've seen we can index, we can use the length of a tuple, so I can say the len of TPL tells me there's 4 items in there. I can also do membership, so I can say A in tuple, and that's true. And tuples support concatenation, just like strings, though this creates a new tuple. So I'd say TPL plus true, for example. And that takes in 2 tuples and returns a third tuple with all the values combined. But note if I ask, what's the value of tuple? It hasn't actually changed. Concatenation returns a new tuple every time. Tuples also support an operation known as unpacking. So if I say A, B, C, D equals tuple, so I put my tuple on the right-hand side of an assignment operator with one variable for every value in that tuple on the left-hand side, then that takes the existing value and unpacks it into those variables. So if I ask what's the value of A, it's the first value, B is the second, C and D each have their values from that tuple. Now it's important to note that you must have the same number of variables as values when unpacking. So if I said just A, B, C equals tuple, then I get an error. There's too many values to unpack. I expected 3 values, but in this tuple there's 4, so it can't do that. Now, as I've said, and I'll say again, tuples are immutable. That's the main thing about tuples versus lists, is that they cannot support the mutation operation. So if I say tuple at 2 is this equal to B, so mutating the tuple at a specific spot, we get an error. Tuple objects do not support assignment. And of course, none of the list methods for doing mutations exist on tuples either, like append or any of those. So you can think of tuples or tuples like lightweight versions of lists. They're more efficient, but they're a little bit less versatile. So they're useful in situations where we have data that we want to contain together, but we don't want to change that data over time. Now, tuples are used implicitly in several Python situations, which is the reason I bring them up in the first place. So for example, we've seen a situation like where I say variable A equals cat, and b equals dog, where we want to swap two variables. So I say a equals cat, b equals dog, and then I would say a equals b and b equals a, but then when I ask what's the value, we only have one of those values, so they didn't swap. We've seen how to solve this by using a third variable, so I could say temp equals a equals b equals temp, and that would, through that third variable, manage the swap of those two values. But there's a Python shorthand for managing this swap as well, by using tuples. So if I have my two values, a equals cat and b equals dog, then the Python shorthand is to say a comma b equals b comma a, which on its face value just looks like you're taking those two values and doing literally the same thing we did in the previous example. But if we ask what's the values of a and b now, we can see they've successfully swapped. And the reason this works is because we're using tuples, which is a third variable sort of implicitly in the background. So this first line here says take the two variables b and a and turn them into a tuple, where b is the first value and a is the second value. Then the rest of the line says, and then unpack that tuple into these two variables a and b. So because we're storing this, so that's not the variable a or b, it's a tuple that's separate from both of them that has copies of those two values. Then the next line says store the first value in the variable a and the next value in the variable b. Normally when we go to do this second part, we've already destroyed the value from variable a, which is still the case here, but because that value is stored in a tuple somewhere else in memory, that's what we're copying into the variable b, not the variable a directly, but this tuple that we've created. So implicitly we're creating this tuple and doing all this extra work, but it's all abstracted away in a very nice shorthand. We get a comma b equals b comma a, and the swap operates as you would expect it to operate in perhaps an English or non-computer science context. Python also allows us to return multiple values from a function in a way that might not seem to use data structures at all. So I'm just going to create a function in the interactions area, which is not a great place to use a function because it disappears once we're done with the interactions, but this function won't be that useful anyways. So I'll say def return 3 words. And this will just have return, and then I'll just return 3 literal strings. So I'll say seagull, pomelo, and foist. 3 random words. So that defines a function, but notice the thing I'm returning is one value, comma another value, comma another value, which, as we've seen in our previous example up here, right at the top of the screen, that's how we create a tuple. Right? It creates a tuple and then returns it. So if I wanted to use this function, I could say return 3 words and just run it, and notice it returns a tuple. Or I could say something like x, comma y, comma z equals return 3 words. Now the variables x, y, and z each have a value returned from that function. So in a way it looks as though no data structures are being used, but in fact Python's creating and returning this hidden tuple, and then we're unpacking that into the variables x, y, and z on the other side. So that's tuples, or tuples if you prefer. They're quite useful in certain situations where we would want to sequence data together into a structure, but not let that structure change over time.